Okay, so welcome to the session. So in this session we are supposed to discuss about the chemistry and especially for the members who are eagerly waiting to capture the GATE exam. Okay, so let's move on to the sessions. So in this session we'll be discussing about the things that let's move on to the content. So first you can see the atomic structure and periodicity, then periodic tables and elements, then Planck's quantum theory and wave-particle duality, uncertainty principle, then quantum mechanical model of atom. So these all the things we'll be discussing in this demo session. Alright, so first of all, the atomic structure and the periodicity. So that is the atomic structure and periodicity. So first of all, let's see what is an atom. Okay, so I think in this image it's clear that what is an atom. You can see the structure of atom, you can see the electron orbits, you can see the nucleus, then the protons, neutrons and electrons. So next move on to what is an atomic structure. As we know, the atomic structure of an element refers to the constitution of its nucleus. Here you can see the nucleus which is composed of the protons and neutrons. Okay, then the nucleus and the arrangement of electrons around it. As we know, the nucleus is composed of protons and neutrons, and the one that is, you can see this rose colored electrons, they revolve around this nucleus. Then the atomic structure of matter is made up of protons, electrons and neutrons. Yes, here we go. The protons and neutrons constitute the nucleus of the atom, which is surrounded by the electrons belonging to the atom. Yes, as we know, the protons, neutrons, everything constitute the atom which belongs to this entire atom. Then the next thing is the atomic number. When we move about the atomic structure, the next thing we need to know about is atomic number. The atomic number of an element, what it describes the total number of protons in its nucleus. Here you can see the nucleus. So the atomic number means it is the total number of protons. Here you can see the red color is the protons. So the total number of protons present in the nucleus, that is known as the atomic number. Okay. Then the neutral atoms. Then what happens to some neutral atoms? The neutral atoms have equal number of protons and electrons. Yes, if it is neutral means the number of electrons and the number of protons will be same. The atoms may gain or lose electrons in order to increase their stability, and the resulting charged entity is called an ion. Yes, then we have a need to know what is an ion. So an ion, it is nothing but the atoms. That is, if an atom gain or lose some electrons, it increases the stability, whether it is a positive charge or as a negative charge. Such entities are known as an ion. Here there is an example, that is sodium chloride, that is Na sodium and Cl chloride. Here you can see the sodium chloride molecule, and here you can see the image how it looks like the crystals. Now here you see loss of an electron, that is the outer shell has 11 electrons and it is giving one electron, that is sodium, then it reaches what, a positive energy, sodium, Na plus ions. Here you can see it is 10 electron, that is loses an electron, sodium loses an electron. Then here it is obtained or it is constituted in this. About to chlorine, it is neutral chlorine atom, then an electron. When sodium gives an atom or it loses an electron, and here you can see the chlorine is receiving that, so it gains an electron, so it is 18 electron minus. You can see here the chlorine ion. So Cl minus, when it is gaining Cl minus, so you can see this chlorine minus ion that is placed here. So this Na plus and Cl minus constitute the sodium chloride NaCl once it loses an electron and the other gains an electron. Okay. Then next, as we know, there are various atomic models. So here are the main atomic models or atomic theories. So the first is Dalton's atomic theory, second is Thomson's atomic model, and the third is Rutherford atomic theory, and last is Bohr's atomic theory. So these are the main postulates regarding atomic models. So all these things will be discussing in the upcoming sessions. Yes. So next is the periodic table. So as we know, all the elements in chemistry is grouped under the table that is known as periodic table. As we have the first periodic table is Mendeleev's periodic table introduced by a chemist known as Mendeleev, and currently we are accepting the modern periodic table where all the elements are placed in various blocks including various groups and periods. Depends upon the chemical properties, electronic configuration and atomic number. So moving on to periodic table. The periodic table of elements is a tabular display of the chemical elements which are arranged by atomic number, electronic configuration and recurring chemical properties. So what are the criteria by which the elements are placed in a periodic table? It is nothing but the atomic number. It's the arrangement of atomic number, electron configuration and recurring chemical properties. Then the structure of the table shows periodic trends. Here you can see the structure of the table. It shows various periodic trends. Then the 7 rows of the table called periods generally have metals on the left and the non-metals on the right. Here you can see metals, non-metals, everything is placed. Okay, the rose color here you can see other non-metals. This all are the non-metals placed. Then here you can see the metals placed. Okay, so the 7 rows of the table called periods. You can see here 7 rows, 1, 2, 3, 4, 5, 6 and 7. These 7 rows are known as periods and there are 18 groups. Here you can see 1, 2, up to 18 groups are there in this periodic table. Then the columns called groups contain elements with similar chemical behaviors. Here you can see various elements. Okay, in this you can see various periods. There are 7 periods and there are 18 groups, and also you can easily identify various chemical elements. That is, the first it is alkali, then the next it is alkaline earth metals, and next it is these all are transition metals. These all are transition metals. Then this rare earth 21, 39, 57 and 71. All those things are transition metals elements. Then you can see actinoids are placed separately, lanthanoids are placed separately, and noble gases all are present separately here. So these all are the various subdivisions. Noble gas here, the 17th is halogens and the 18th is noble gas. So all these are separately kept in the periodic table. Mainly depends upon the atomic number, electronic configuration as well as its chemical properties. Okay. Then here you can see the periodic trends in properties of elements. What are the periodic trends? So here this is the model of a periodic table. As you can see, the atomic radius, it is increased across. That is, if we move down the periods, atomic radius of elements is increasing. Then here when we move across a row, what we can see, atomic radius increases from right to left. Like that, ionization enthalpy, it increases from left to right. Electron affinity is also increased from left to right, hence it reaches the noble gases. And electron affinity towards a period increases from bottom to top, and also ionization enthalpy. Okay, then let's see atomic sizes. With the increase in atomic number, the atomic radii in the group will increase. On the other hand, the atomic radii decreases from left to right in a period. That is, left to right in a period, atomic radii. Yes. Then next is ionization enthalpy. Ionization enthalpy, that is, decreases down a group but increases across a period. Ionization enthalpy, here you can see, that is ionization enthalpy. It decreases down a group, increases a period. So across period it will increase, and in groups it will decrease. Okay, then electron gain enthalpy, that also electron affinity also tends to become less negative down a group and more negative across a period. So across a period it will be increasing, and towards a group it will be decreasing. Okay. Then next is electronegativity. Electronegativity decreases down a group. Electronegativity, here you can see it will decreases down a group, and also it will increases across a period. So in periods it will increase and groups it will decrease. All right. Then chemical reactivity. The chemical reactivity is the lowest in the central, and its chemical nature is being located in the central part. So its central, it will be low and high at the two extreme periods. So in the extreme two periods, it will be high, and the central portion, it will be low. So these are the various trends in periodic table, that is atomic size, ionization enthalpy, electron gain enthalpy, electronegativity, and chemical reactivity. Okay. Then the next thing, so that's all the main content about the periodic. Then from moving to periodic table, the next thing we need to know is the dual natures or Planck's quantum hypothesis. So in order to know that, first of all we need to know what is black body radiation. So this is very simple concept, that is black body radiation. It is just nothing but solids when heated, it emit radiations varying over a wide range of wavelength. As we know, when we heat some solids, it may show or it may emit some radiations, depends upon the temperature is given to the solid. So what temperature is given to the solid, it will emit some radiations, and that of maybe of different wavelength. So now you see an example. When we heat a solid, the color changes continues with further increase in temperature. As the temperature of the object is increased or the solid is increased, the color also may change, depends upon the temperature. So we can say an ideal body which can emit and absorb radiation of all frequencies is called a black body. Then you might wonder, what is a black body? A black body, in the sense, it can emit and it can absorb radiations of all frequencies. Whatever the radiation falls on it, it will absorb. Such an ideal body, it can emit as well as it can absorb whatever the radiation falls on it. Such a body is known as a black body. Then the radiation emitted by such bodies, the radiations emitted by such bodies is known as black body radiations. Okay. Thus, we can say that variation of frequency for black body radiation depends on the temperature. So we can surely say that the temperature is the principal component for black body radiation. Okay. Then, by knowing the concept, what is black body and what is black body radiation, we'll be able to know what is Planck's quantum hypothesis. So Planck's quantum hypothesis or Planck's quantum theory explains two important things. That is, different atoms and molecules can emit or absorb energy in discrete quantities only. That is, different molecules and atoms, it will emit different types of energy. That's in discrete quantities only. The smallest amount of energy that can be emitted or absorbed in the form of electromagnetic radiation, that is known as quantum. So he explained the small thing that is quantum. It means it is the smallest amount of energy that can be emitted or absorbed in the form of electromagnetic radiation. So it is a small amount of energy that can be absorbed or emitted by an electromagnetic radiation. That is known as a quantum. Then the energy of absorbed or emitted is directly. Then what is the speciality of this energy emitted or absorbed? The energy of the radiation absorbed or emitted is directly proportional to the frequency of the radiation. So it is directly proportional to the frequency of the radiation. Whatever the frequency falls on it, that will be directly proportional to the energy of radiation. Okay. Meanwhile, the energy, that is the equation. Now we see the equation, E is equal to h nu. E is equal to h nu. E is the energy of radiation. E is the energy of radiation. Then h is Planck's constant, and it has a constant value of 6.626 into 10 raised to minus 34 joules per second. It is the value of h. Then nu is the frequency of radiation. So E is equal to h nu, where E is the energy of radiation, h is the Planck's constant, and V is the frequency of radiation. So this is the main two postulates of Planck's quantum theory, and also the equation E is equal to h nu. So this might be a possible question for all the exams. So you remember the question, that is Planck's quantum theory, and also the expression given to describe this theory. Okay. Then from this quantum hypothesis, there we have originated the wave particle duality, that is the dual nature of particles. So what it might be, wave particle duality helps to understand the particle and the wave nature of light. So why this principle is used is that to understand the particle and the wave nature of light. So to understand the wave nature of light or the emissions, we use this dual behavior of wave. Okay, that is duality. Then, based on the idea that light and all other electromagnetic radiation may be considered a particle or a wave nature, in 1923, a physicist Louis de Broglie suggested that same kind of duality must be applicable to the matter. So the same kind of duality must be applicable to the matter. That is, de Broglie suggested that. What he proposed is that any particle of matter having momentum is represented by P has an associated wavelength. Any particle that is associated by a momentum, as we know various particles have a momentum. So any particle which is associated by a momentum P has an associated wavelength lambda. So a momentum P and a wavelength lambda. So we can write de Broglie wavelength equation. Lambda is equal to h by p, where h is the Planck's constant, lambda is the wavelength, and p is the momentum. Okay, that is h is the Planck's constant. Then for a particle mv, that is mass into velocity, and the wavelength is lambda is equal to h by mv. So this equation can be applicable to solving the problems relating to wave particle duality. Okay, this was finalized by the physicist, that is Louis de Broglie. Okay, then here you can see an image, that is the wave nature. Here you can see the elevation and the wave moving. Then here the upraised portion is known as the crest. Then here you can see the amplitude of the wave. Then this portion is known as the trough. Here you can see the trough, and here you can see the trough and the crest of the wave, and the area between the adjacent crest or trough is known as wavelength. That's between these two adjacent trough, okay, or crest is known as the wavelength. So this might be the wave particle dual nature. Okay. Then next is, moving with this dual nature, we are supposed to discuss about the Heisenberg uncertainty principle. Hence it is known as uncertainty principle. It was introduced by this chemist, that is Heisenberg. Heisenberg uncertainty principle, what it states, that it is impossible to measure or calculate exactly both the position and momentum of an object. So it was a simple concept that Heisenberg introduced, that it is impossible to measure or calculate exactly both the position and momentum of an object. We cannot easily calculate the position and momentum of an object. This principle is based on the wave particle duality of matter. So as we discussed the wave particle duality, this Heisenberg uncertainty principle is based on that duality. The uncertainty principle says that both the position and momentum of a particle cannot be determined at the same time and accurately. So what this Heisenberg uncertainty principle states? It states that both the position and momentum of a particle cannot be determined at the same time. Same time we could not find the position and momentum of a particle accurately. That is Heisenberg uncertainty principle. The rest of the position and momentum is at all times greater than h by 4 pi, the formula for Heisenberg uncertainty principle. So now the result of the position and momentum, that is, it is given by h by 4 pi. Then in such a way, the Heisenberg uncertainty principle or the formula, it can be formulated delta x, that is change in x by change in p, that is delta x in delta p. Then x is the position and p is the momentum, that is change in position and change in momentum. It might be greater than or equal to h by 4 pi. H by 4 pi is the Heisenberg uncertainty, that is the position, the result of position, that is h by 4 pi times it will be greater, that is the position and momentum. Change in position and change in momentum will be greater than or equal to h by 4 pi times, whereas h is the Planck's constant, pi is 3.14. Okay, h is Planck's constant, the value is 6.626 into 10 raised to minus 32. Then here you can, x is the position of the uncertainty and p is the momentum of the uncertainty. Okay, so this is how we explain Heisenberg uncertainty principle. So all these equations will be used in solving various problems related to Heisenberg uncertainty principle. So in various exams, you are supposed to see various problem sessions regarding Heisenberg uncertainty principle rather than in theory sessions. Okay. Then now here is a simple topic, that is quantum mechanical model. Here we are only explaining what is a mechanical model of atom. Here you can see Bohr model of atom, electron orbits, and here you can see the cloud model or quantum mechanical model. Here you can see the nucleus completely, and we are pointing out various electrons, protons and neutrons. Okay, a model of atom that derives from the Schrödinger wave equation and deals with probabilities, wave function. Give only the probability of finding an electron at a given point around the nucleus. So in this mechanical model, how we are finding is that among this a particular point, from a particular point we will be locating an electron. Okay, finding an electron from a given point around the nucleus. It might be of any point, and from there we will be finding an electron. That is known as quantum mechanical model. It is mainly applicable in hydrogen atoms and various other atoms also. To finding electron, we are using this quantum mechanical model for hydrogen and other atoms. So what is the difference between other models and quantum chemical model is that here we are finding an electron from a given point around the nucleus. That is the main feature of quantum mechanical model. Okay. Yes. So thank you for the session.